Hello friends, in this video we'll learn sequences of real numbers. Let's see the definition of sequence of real numbers. A sequence of real numbers is also called as a sequence in R. A sequence of real numbers is a function from set of natural number n containing elements 1, 2, 3, 4 and so on to the set of real number R. This set of real number R is a set containing all numbers belongs to the real line. The sequence of real numbers is denoted by round bracket xn, round bracket yn, round bracket an, round bracket bn, and so on. See, the value of a sequence xn at a natural number n is given by xn, and xn is called nth term of the sequence xn. Let's see the examples of sequences of real numbers. Let xn is equal to 1 by n for all n belongs to n. Means we are taking, suppose nth term of the sequence xn is 1 by n, then the sequence xn is the sequence whose first term is 1, second term is 1 by 2, third term is 1 by 3, fourth term is 1 by 4, and so on. Suppose yn is equal to n square for all n belongs to n, then the sequence yn is a sequence whose first term is 1, second term is 2 square 4, third term is 3 square 9, fourth term is 4 square 16, and so on. Let's see next example. Let n is equal to n minus 1 plus n minus 2 for n greater equal 3, and suppose a1 is equal to 1 and a2 is 2, then the sequence an whose first term is given, that is a1, which is 1, second term is a2, that is 2. Sorry, here we have to take a2 is also 1. Okay, well, a2 is also 1, the second term is 1, then third term is a3 is equal to, you can note that a3 is equal to a2 plus a1, that is 1 plus 1, 2. The third term of the sequence is 2. Fourth term is nothing but a3 plus a2. Here we have a3 is 2, a2 is 1, so a4 is 3. You can note that nth term is nothing but addition of its first two previous terms. Means 2 is 1 plus 1, 3 is 1 plus 2. Next term of the sequence is 2 plus 3, that is 5. Next term is 3 plus 5, that is 8. Next term is 5 plus 8, that is 13, and so on. And this sequence is called as Fibonacci sequence. This is a sequence whose pattern is observed by mathematician Fibonacci, therefore it is called as Fibonacci sequence. Let's see what is meant by constant sequence. Let a is a real number and xn is equal to a for all n belongs to n. And then the sequence xn is equal to, first term is a, second term is a, third term is also a, fourth term is also a, and so on. See, you can note that this is a sequence all of whose terms equal a, and this type of sequence is called the constant sequence a. Here you can note that a is a real number and we are taking xn is equal to a for n equal to 1, 2, 3, 4, and so on. Means first term of sequence is a, second term is a, third term is also a, fourth term is also a. Actually, all terms equal a, and this type of sequence is called a constant sequence a. For example, suppose we have sequence whose first term is 1, second term is also 1, third term is also 1, fourth term is also 1, and so on, is the constant sequence 1. means this is a sequence whose all terms are 1. Example 2. Consider we have sequence whose all terms are 0. Means this is a constant sequence zero. Suppose we have a sequence whose all terms are -2. Means is the constant sequence -2. Means you can say that a constant sequence means a sequence whose all terms are equal. Let's see one note. Let xn be a sequence of real numbers. Then the set of all xn such that n belongs to n is called the set of all terms all terms of the sequence xn. For example, let xn is equal to 1 for all n belongs to n. Then xn is a sequence whose all terms equal a, and we have just seen that it is a constant sequence 0. And here you can see that the set of all terms of the constant sequence 1 is equal to a set containing single element 1. Means we have to consider a set containing terms of the sequence. See, and in a set we don't repeat the elements, right? Therefore, the constant sequence 1, the set of all terms of the constant sequence 1 contains single element, that is singleton 1. Let's see another example. Let xn is equal to -1 raised to n plus 1 for all n belongs to n. Then the sequence xn is equal to a sequence whose first term is 1, second is -1, third term is 1, fourth term is -1, fifth term is 1, sixth term is -1, and so on. And here the set of all terms of the sequence xn contains two elements which are 1 and -1. Means here you can see that the sequence contains infinite terms, but the set of terms of the sequence may be finite. In the first example, the set of terms of the constant sequence 1 contains single element, that is 1, and in the second example the set of all terms of the sequence contains two elements which are 1 and -1. Let's see another example. Let xn is equal to 1 by n for all n belongs to n. Then the sequence xn is equal to a sequence whose first term is 1, second term is 1 by 2, third term is 1 by 3, fourth term is 1 by 4, and so on. And this set of all terms of the sequence xn is a set containing infinite elements 1, 1 by 2, 1 by 4, 1, 1, 1 by 2, 1 by 3, 1 by 4, and so on. See here, the set of all terms of sequence is infinite set containing elements 1, 1 by 2, 1 by 3, 1 by 4, and so on. Let's say another example. Let xn is equal to n square. Then the sequence xn is equal to a sequence whose terms are 1, 4, 9, 16, 25, and so on. And in this case, the set of all terms of the sequence xn is a set whose elements are 1, 4, 9, 16, 25, and so on. See, in the sequence, the order is important, but in the set, order of is not important. Okay. In the next video, we'll see the limit of a sequence and convergence of sequence of real numbers. Okay. Thank you for watching the video.